Hey there, welcome back to the GM6L Diagnostic Troubleshooting Series. This video is going to focus on the valve body. So basically testing and evaluating and servicing the valve body assembly, including the spacer plate on any General Motors 6L series transmission. So that's going to be your 6L45s, 50s, 80s, and 90s. So we're going to cover a fair amount of material in here. We'll first talk through the valve body in general, and kind of explain the role that it plays in what I call C3, communication, command, control, the transmission. Discuss various drivability symptoms and problems that have their roots or causes within the valve body, and then from there we'll comprehensively test this valve body using the Sonex vacuum test machine, along with their test plates that are specifically designed for each of these valve body halves. So one of the major areas of the compensator feed system in these transmissions is the valve body. In fact, the compensator feed has the heart of this system in the valve body, and then all of its other touch points, or tentacles, or however you want to describe them, elsewhere in the case kind of radiate, if you will, from this central mechanical locus of control. And that locus of control is the compensator feed regulator valve. Alright, and that's in the lower valve body, so we'll test that along with all the others. But the reason I mention that is if you had watched the compensator feed system deep dive diagnostic and troubleshooting video that's a part of this series, you'll have a really good understanding of how that system works, what it is, the role that it plays in the overall functioning of the transmission, and how important it is. And as it applies to this video, you'll understand all the different touch points or relevance it has to the valve body itself. So the other thing that I want to make mention of is the relationship between the valve body, the TECM, and diagnostic trouble codes. So a lot of the drivability symptoms that folks will experience with these transmissions, including clunky, jerky, bumpy shifting, inconsistent shifting, harsh downshifts, harsh upshifts, whether they be intermittent or chronic, and other related conditions, if you will. A lot of these problems have their roots in the valve bodies, either the upper or the lower, but diagnostic trouble codes will set that would lead you to believe that the problem is in the TECM. And so if you just simply take the diagnostic trouble code, say like a clutch pressure control solenoid performance code, for example, at face value, and you go out and you spend money on the TECM, which could cost you anywhere from $600 to $1,000 depending upon where you source it, that money may have been ill spent, meaning wasted, because the true heart of the problem is not in the TECM, it's in the valve body. So these transmissions and their associated computer controlled diagnostic logic can only cover so many different things and so many different areas within the unit itself to report upon potential areas of concern and weakness. So whenever you have performance codes, and I say performance codes because they're not really voltage codes per se, it's not like this is unmistakably an electronic or electrical problem. It is a performance problem. There's a 50-50 chance that you have a mechanical problem in the valve body and not the TECM. So that is why this kind of testing is so important, because you want to be able to definitively rule in or rule out something like the TECM before you spend a whole bunch of money replacing it, and only to have the problem represent shortly after you put the vehicle back on the road. Now, if you're a DIY or you don't do these transmissions on a regular basis, and you're just trying to either A, learn more about how they work and what can go wrong with them and where, then you may not want to spend the $500, $600, $700 it's going to cost you to acquire all this test equipment. If nothing else, though, you'll take away a lot of important information so that you're now armed to have better, more intelligent conversations with shops. And at least from my standpoint, the most important value add here is that you can differentiate a shop that knows these transmissions versus one that is full of shit and is just trying to take your money. They're not all that hard to work on, but the main challenge that anybody, whether it be a shop, a professional, or whether it be yourself like a DIYer, is going to have when working on these later model units is understanding all their quirks and proclivities and all their areas of weakness, truly understanding them from a theoretical perspective. And that's kind of the purpose of this whole video series, is to, you know, pull the cover off of that stuff and give you a glimpse inside under the hood, if you will, and, you know, allow you to better understand these transmissions, you know, arm you with that knowledge, because knowledge is power, right? So anyway, this video will cover the valve body. We'll go over you know, a few other things like the spacer plate and the check balls, and then I'll wrap up with a vacuum test of the stator support, because a lot of the hydraulic driven problems in these units are actually in the pump cover. So, you know, stator support / pump cover, those two terms are interchangeable. All right, let me go ahead and reposition the camera. I want to cover the spacer plate first, and you know, talk a little bit about that, and then we'll walk through all this test equipment, you know, kind of show you in detail, you know, what it is and how everything works, and then we'll set it up on the two valve body halves, each of these two plates respectively, and we'll perform a vacuum test, and we'll ascertain the health of all of the valves, you know, and the different parts of the valves, you know, the inboard and outboard spools and such in this particular valve body. Alright, so like I mentioned, first thing I'm going to touch on are the check balls. These check balls, at least in this transmission and you know, a lot of the late model units, frankly, they wear. And they wear more aggressively than in prior units like the Legacy 4-speeds or your 3-speeds. So they're made of like a material called Torlon. It's generally speaking a durable material, but for whatever reason these check balls in this transmission like to wear. And so I'm not going to cover all of them. Later model units 2014 and up had 8 check balls. All prior years had 7. You can retro the 8th check ball back to all valve bodies through 2010. As long as you run the 14 and up spacer plate. So I'll do a separate video on like all the different changes, the vintages, and the interchange rules. I mean, that's kind of outside the scope of diagnosis and testing, but I just wanted to make mention of that because a lot of folks are, you know, on the used market looking for replacements, and that's kind of top of mind, you know, which one will work with which transmission and what year and model and all that. The other thing you need to be mindful of when it comes to interchanging is not all these valve bodies are interchangeable as a whole, you know, the whole assembly. They are specific to makes, models, and years, not just associated with the spacer plate, the entire valve body. So again, it'll be a topic for a separate video, but just be aware that they can't all interchange. So if you want a kind of a primer on how to tell the difference, you want to look in these respective areas down here on the valve body casting. Okay, this is going to be the upper valve body. It's going to have a barcode, and then there's going to be embossments here. So you'll have A, B, C, and D. Depending on which boss is shaved off or machined down, will kind of indicate you know, what specific application or year or vintage that this particular casting is associated with. Alright, and then same with the lower valve body. Okay, they also use a barcode and a series of embossments. So you have D, E, and F. So this is shaved off. So if you're looking for used valve bodies, whether you're a builder or a DIYer, you want to pay attention to the castings and make sure you match up the embossment patterns that you see, you know, based on what you saw here for your valve body. Okay, back to check balls. So the two most important check balls, in my opinion anyway, in this excuse me, in this assembly are going to be the number 1 and the number 5 check ball. And they are located on the spacer plate here, and the spacer plate sits on the valve body here. So you can see the 2 seating locations for each respective check ball. Let me get that out of the way for a second. So these are all bathtubs, And anytime you have a bathtub, if you want to know if a check ball is supposed to go there or not, all you need to do is look at the hole pattern in the spacer plate. So if you see two circular holes for seating locations like this, side by side over that bathtub, then you know a check ball must go there. At least 99% chance that a check ball belongs there. Now, that's not always going to be true. There are exceptions to that, but that's a general rule of thumb, and it applies here. So, what are the number 1 and the number 5 check balls? Why are they so significant, and what do you need to know about them? So the number 1 check ball is what's called your drive check ball. Okay, basically when you put the transmission into drive from park, neutral, or reverse, this check ball will seat and allow oil to flow to the 1, 2, 3, 4 clutch, enabling you to move forward. Now, the main problem with this check ball is it likes to wear out and it'll like to migrate. And if it punches through the seating location here, or it migrates elsewhere, in other words, it gets stuck somewhere else outside that bathtub, alright, say here, then you're not going to have any movement whatsoever in any forward range setting. I mean, you'll just be dead in the water. It won't move. You'll have reverse, but you won't have any forward movement. And it may appear all of a sudden. In other words, vehicle drove perfectly fine yesterday, you go get in, drive it today, go somewhere, and you throw it in drive and nothing happens. It could be that number 1 check ball. It is very common for them to wear once the miles, get significantly over 100,000 or so. Alright? The number 5 check ball is pretty much the same story, except it applies to reverse. So, same situation. If this number 5 check ball wears and it migrates, then you're not going to have its seat against the drive location, allowing fluid to flow into the 3.5R clutch apply circuit when you throw the vehicle into reverse. Okay, you'll have no movement in reverse whatsoever. So, all of the major hydraulic correction kits on the market, including Transgo's reprogramming kit and Sonic's zip kit, have check balls that come in those kits respectively. So you're going to go back with it and you're going to install one of those kits, which I highly recommend. I would never assemble one of these transmissions without a hydraulic correction kit of some sort, and those are the 2 that I use. You want to make sure you install the check balls that they provide to you. They're replacement Torlon, and you won't have any issues as it relates to check balls in this transmission. Now, the other check balls are important too, and they can be sources of drivability symptoms. I will go ahead and put a link in the description of this video to the ATSG, or Automatic Transmission Service Group manual, so you can refer to that manual for check balls, and I'll annotate the video with whatever page you need to look at. But they give you a description of each and every check ball location and what it does, and you can use that information to maybe determine if check balls are the source of your drivability symptoms. Alright, when it comes to the spacer plate itself, as you can see, it's the bonded sheet steel and gasket variety. GM and other manufacturers started moving to this sort of setup with later model units. At the 4L60Es, I want to say 2007, 2008, somewhere in that time frame. These always had the bonded spacer plates. There was never any kind of plate where the gaskets were independent. But don't reinstall this after you've taken these 2 halves apart. Alright, you do run the risk of having cross leaks between the circuitry. Alright, you don't want to just assume that it's going to reseal. So always replace your spacer plates, and that's true of really any transmission that has that kind of bonded steel and gasket, dual-sided setup. And again, I'm not crazy about it because it costs more money to replace them. I mean, every transmission you build, you got to buy a whole new plate. Okay, let me talk about the Sonex test equipment. Now, if you're not familiar at all with the Sonex vac test machine itself, basically it is a machine using an air pump along with a vacuum gauge to draw vacuum on any given valve train in this or whatever valve body, so that you can ascertain how well that valve is sealing in its respective bore when it's either inboard or outboard, and in some cases whether it's stroked in the open position, or in most cases it's when it's just at rest. But the whole idea here behind this testing is to determine if the valve body is the source of a given set of symptoms or an out-and-out failure of a given transmission. So for rebuilders, it's pretty much a must-have. Like, I don't know, unless you just don't work at all on any kind of newer, later model units, meaning 4L60Es or equivalent Ford and Dodge transmissions starting in the late 80s, early 90s on up. If you just solely work on the older stuff like 700R4 vintage and back, then maybe it's not a must-have. But if you're doing any kind of frequency on any later model units than that, your 4L60s, your 4L80s, your 6Ls, 8 speeds and 10 speeds, which I'm not familiar with the 8 and the 10 speeds, I'll just disclose that up front. But anything that is testable with this test equipment, you want to have it. If you're a DIYer, maybe it could be a coin flip. And if you really want to invest in the equipment, I'd say it's definitely worth it. But if you're only going to do 1 or 2 transmissions, you'll have to decide if it's something that you want to spend the money on. But if nothing else, it's an incredible source of information and the best way to learn about the health of your hydraulic systems. So anyway, the tester consists of the gauge, and then you have 2 test hoses or leads, a test block, a little gasket, and then you have 2 adjustment valves. You have a pump valve for the vacuum pump itself, and then you have a bleeder valve. And so before you use this tester at any given time, you need to calibrate it. So I'll go through that now. So the first thing you're going to do is you're going to take your hose that's coming out of the test port here, take it out of the test block, and go ahead and put it into the calibration receptacle, and make sure it's all the way in. Alright, now what you're going to do is you're going to turn on the machine. Okay, now I used this just a little while ago, not today, but a few days ago, to test a 4L60E valve body, and I calibrated it then. But you'll notice, assuming I can get the hoses out of the way, the vacuum gauge is not reading where it needs to read. So let me zoom in on that, and then we'll kind of walk through the rest of the calibration. Okay, got a little bit better view? So when you turn this machine on, and you're in the calibration receptacle, you want to see this read a steady 5 inches of lift. Okay, 5 inches. So what you're going to do is you're going to adjust your pump valve until it reads 5 inches. Alright, turning it counterclockwise will increase vacuum. Turning it clockwise will decrease it. Alright, the next thing you need to do is place your finger on the calibration receptacle port on this side of the body. So that's this little hole right here. So we'll go ahead, we'll put a finger, and we want to see this reading 25 inches of lift. We're about 25 and a half, so we'll go ahead and we'll make an adjustment. Counterclockwise here reduces lift, clockwise increases it. So when we let off, we want to see we have 5 inches. Put it back on, we have 25 inches. So now the machine's ready to use. Okay, go ahead and remove your hose from the calibration receptacle and plug it back into your test block. And then from there, if you do not have these test plates, then what you're going to do is you're going to, following Sonex's vac test instructions for whatever transmission you're working on, you're going to use the little gasket that comes with the test block. This comes in the main kit. And then depending on which hole you need to use, you're going to put the gasket over the valve train in question in the location specified in the instructions, which we'll look at in a minute. And then with the machine on, you're going to take a reading. So general rule of thumb with all this vacuum testing, no matter what transmission you're working on, whether it's a valve body or a pump, doesn't matter. You want to see between 15 and 20 inches of lift. That's like the ideal range. The kind of it's okay but range on either side of that is going to be between 13 and 15 on the low side and between 20 and 22 on the high side. And the reason I say that is because there's been more than enough occasions where I've been in a jam and I couldn't find either a replacement valve body or the customer couldn't afford a valve body, and we were at like 13 inches or so, and put the transmission back together. It was a daily driver, not high performance, and put it back on the road and it was fine. Okay, but my preference is to be at 15. If it's high performance, mandatory. Someone spending $3,500, $4,000 on like a high performance 4L60, 4L80, or $6,000 on one of these things, they can afford to spend the extra money it's going to take to either fix this valve body, which is already going to be baked into the price anyway due to a hydraulic correction kit, or buy another one, a remanufactured valve body, if for whatever reason the correction kit is not sufficient to restore the sealing integrity of a given bore. And that's pretty rare, to be honest, especially with these. In most cases, there's something available. So you have oversized clutch boost valves, you have replacement clutch regulator valves, you have all the different other valves that come with either the Transgo or the Sonics kit, and sometimes you will marry both of those kits together. You may want to decide to purchase the Transgo's clutch select valve kit and use that in conjunction with the Sonic zip kit, especially if you identify weakness in those particular valves. So, it all depends. I mean, the aftermarket has an incredible amount of parts, and there's just a ridiculous amount of support available for most GM, Ford, and Dodge transmissions, and frankly most foreign stuff too. So, all right, let's talk about the test plates. Okay, the test plates are purchased separately, independent of the vac test machine itself. And Sonics has started to produce these, I want to say some point in the last 5 years. I don't know exactly when. I've started seeing them about 2 or 3 years ago. And so I have the test plates for the 4L60 and the 4L80, and I have videos showing you exactly how to use those on those respective transmissions. We walk through the whole process just like we're going to do here. With the 6Ls, obviously, because you have 2 castings, you're going to have 2 test plates. So here's the lower test plate or test block for the lower valve body. That's the valve body with the manual valve. And as you can see here, it says Sonics 6L 45, 50, 80, and 90 lower. Alright, so this will bolt to the lower valve body. I'm going to have it kind of, I guess it'll go like this, but you'll bolt that to the lower valve body, and then the plate sitting back there is for the upper valve body. Alright, so let's take a look at the instructions real quick, and we can get a sense for how this stuff goes together and how to test each of these each of these castings along with the stator support. So first off, the instructions on the first page show you just how to set up the plates and install them onto their respective castings. Okay, you have alignment pins, and you have bolt holes, which they call it optional, but I mean you really need to install your clamping bolts, if you will. And then they have push pin locations, which in my opinion those are optional. I never install them. All right, so you'll see how that goes. Then they give you an overview of the instructions on how to use the vac test equipment itself, along with the plate. How to install it, the plate onto each respective casting, and then just a diagram of the tester itself, and kind of walks you through on how to set it up and get it going. Okay, so the next 3 pages are what I call the substantive portions of these instructions. So we have the stator support or pump cover, whatever you want to call it. We have all the different test locations here, along with a set of drivability symptoms whenever weakness is present within that particular valve, or whether it's not sealing. Then it'll get into the lower valve body here. This is for a 6L80. That's what these valve bodies are. These are from a I think a 2007 or 2008 6L80E in a out of a either Tahoe or maybe a Yukon Denali or something like that. I don't know exactly what it was, a core. So you're going to have test port locations here. Now in most cases you will be able to use your test block, but in some cases you will not be able to use just this by itself. You'll need the test plate to get an accurate reading on the health of that particular valve train and or bore. Okay, upper valve body, ditto, all the different symptoms and associated with each particular valve train or each particular valve. And then last page of instructions is going to show you just an exploded diagram. Okay, I'll put the link in the description to to Sonic's webpage for these instructions, so you don't have to go fishing for it or worry about trying to take screenshots of this, because I'm moving this paper all around, so I know that kind of not really lends itself to taking a screenshot. But this last page is just a template they provided to you, so you can record all your results, and it looks like it's set up to record the testing of multiple different valve body castings. I never use it. I made my own. To what extent you can see this, I don't know, but we're going to use each of these test sheets to record all of our values. This one here is going to be for the lower valve body and for the stator support, and then this one is going to be for the upper valve body. So for all my customers where I can comprehensively test valve bodies like this, whether it be one of these transmissions or a 4L60 or whatever, I produce a sheet for every one of those units, and it goes in the customer's file. So if I have to do multiple iterations, like maybe I find a valve that's not sealing adequately, then I'll install like a corrective valve and I'll retest it, and then if it passes, great. If not, then we'll have to do other things. So I prefer to use drop-in valves as kind of my first line of recourse to repair or address inadequately sealing valve trains. If for whatever reason a drop-in valve is not available and we got to go to a special valve that's oversized, it requires tooling, reamers, and fixtures, then that's what I'll do. But it is considerably more expensive, and the tooling itself, which all of it's available from Sonic's or Transgo, is more expensive. The Sonic stuff is a lot more expensive. Transgo makes reamers, and they'll come with a kit that'll service maybe anywhere from 5 to 6 transmissions, something like that. And they're not as expensive, and they're a little bit more straightforward, a little bit more focused on either like part-timers or DIYers from a cost perspective. Sonics seems to be more focused on the shops. They're doing these in large volumes, and kind of have the money to spend on all that fancy tooling. In fact, this thing here is part of the Sonics whole jig and fixture and reamer comprehensive kit, and I use it to reman 4L60 and 4L80E valve bodies primarily. There are reamers for these. You can install oversized clutch boost valves. Sometimes they get worn. You can put an oversized clutch boost valve, and they're from a few different folks that have those out there on the market, for a few different companies. All right, I'm going to go off camera to install this stuff, and then we'll go ahead and we'll begin the test. And then from there, once we are done the test, we'll kind of recap the results, ascertain the overall health and viability of this particular valve body. And then what I will do is I actually filmed the assembly here. I cleaned out, took out all the valves, cleaned out both castings, threw them in the hot tank, and reassembled. I filmed it as a demo. I never posted it to the channel, but maybe I will. I probably will. I mean, if nothing else, I'll show you what a stock 6L80 transmissions valve body looks like as far as orientation and arrangement of all the valve trains. But anyway, I like to do that because I want to get a baseline. So we have a baseline kind of state of the union when it comes to the health of the whole casting for each of the upper and the lower respectively. and I'll test them before I install any kind of corrective parts, you know, from Sonex or Transgo, because from a diagnostic standpoint, I want to know what contributed to the failure of the unit. I mean, if the torque converter failed, I mean, those torque converters are complete pieces of garbage. The clutch in them is like 20 thousandths of an inch thick. It should have been 3 times that. They fail on their own accord, but you know, most of the time anyway. But sometimes they fail due to weakness in the converter clutch regulator valve or limit or control valves, and that would show up in testing, and, you know, via this test equipment. So that's why I like to do it. I want to be as certain as humanly possible why a particular 6L transmission failed, or really any transmission, but like, you know, we're talking about 6L, so that's why I say 6L. There's a myriad of reasons and a variety of causes, you know, and like I said, this whole series kind of touches on each of them, you know, based on whatever video you're watching. But if you do these in volume, you don't want them coming back. It's best to invest upfront in the time and the money to get this type of equipment so that you can de-risk that part of the build. If you're a DIYer, again, it's a judgment call. Do you want to spend the money, or, you know, you rather outsource that kind of work to a shop that has this equipment ready to go? All right, give me a second. We'll deal with this, get it all set up, and then we'll start the test. All right, so we're going to start with the lower valve body, but there's a couple things we need to do first before we begin the testing. So first, take out your manual valve. You're not going to need it. It's not going to be tested, and these, generally speaking, don't have a problem with manual valves in terms of sealing anyway. For example, the Ford 5R110 transmissions do, and, you know, it's a chronic problem with them. But generally speaking, GM transmissions, you don't have to worry about that too much. The next thing you need to do is remove the clip, the bore plug, and the shuttle valve from the TCC regulator valve train. And the instructions have you install a 1/8 of an inch thick nut between the shuttle valve and the regulator valve. So it's going to be on page 4, and this is what they tell you to do there. So 125 thousandths thick, and that allows the shuttle valve to be held fast against the bore plug so that you can get an accurate reading when you test it. Okay, so I took a 1/8 of an inch thick nut, you know, little one, and I kind of ground off the hexagonal edges so that there wouldn't be any issues with interference with the inner bore. And then just go ahead, reinstall your bore plug and your retainer clip. All right, next, what we're going to do is we're going to have to bolt the test plate to the valve body. So reorient it, and then what we need to do is install from the hardware kit 2 alignment pins. Okay, the upper valve body does not take alignment pins, but the lower one does. So here are your 2 alignment pins, and then you're going to lift up on the gasket. Sonex calls this a membrane. So you lift up on the membrane and you install each of your alignment pins. Okay, there's going to be a small recess to allow for that radius to settle in there so it's flush. And this will allow the test plate and all the ports to line up perfectly with the ports that need to be tested in the valve body. Okay, so I've written all of the different valve locations or test locations here so that you know what they are, and I'll call them out as we move through them. So just go ahead, line up your locations. There we go. And then the next thing you need to do is take your clamping bolts, and you're going to put them through in each of their respective locations here. So one here and one here. Alright, flip it upside down. Now for this one, you don't have enough threads to go all the way to the base, so I'll just take a washer, a nut, and another washer, and then I'll install the wing nut. Okay, the castellated nut and these two other washers don't come in this kit. This is just something I used, from what I have laying around in the shop. And then you can use another washer up here too if you'd like. It's not necessary. These nuts, the hex heads on these nuts are 7/16, but I found that you really don't need to wrench on it. Just hand tight is sufficient. And when we conduct the test, there's going to be some spots where you have to kind of hold down, on the plate to get a good seal, especially like in the middle. All right, the last thing you want to do is find something. This could be a block of wood. I just happen to have a piece of steel, but something to stabilize the whole thing so it's not flopping around on you. All right, let me get this hardware in the bag. Okay, you see a whole bunch of crush washers. They're used on the upper valve body because we got to do that whole nut and washer deal on both of these clamping bolts. Alright, so here's our test sheet. We're going to test everything up here with this first pass, and then we'll go through and we'll test everything on page 2, which is the upper valve body, after this one's done. And then I'll kind of summarize the results of the test, and then from there we'll go ahead and move into the pump cover / stator support and test the valving in there. Alright, let me get the machine turned on, and then we'll get started. Alright, so we're going to go from top to bottom, left to right. So we're going to start with the TCC regulator valve train. So we have the bore plug, the inboard position, and then we have, that's for the shuttle valve, and then we have the regulator valve, inboard position and spring. Okay, so the first location is going to be 302D. Okay, bore plug is giving us 22 inches. Alright, next is 302C. This is going to be the outboard position for the shuttle valve. And this is why you put that nut in there. That's going to be 20 inches, just shy, maybe let's call it 19 and a half. Now we'll do inboard. And it looks like we're at 15 and a half. And then on the inboard position for the regulator valve, we're at 22. That's going to be 302A. Is that, no, maybe 21 and a half. Sorry, 21 and a half. Okay, so 304A is going to be your inboard spool for the clutch select valve number 3. Okay, we're at, looks like 18 inches of lift, and I'm applying a little bit of downward pressure here. So like I said, there's going to be spots where you have to do that. So let's do 304B. So it looks like 17 and a quarter, but I'm just going to record 17. Okay, now we're going to come up to the compensator feed balance spool. Okay, if this is worn, then this by itself would explain clunky, bumpy shifting throughout the drive cycle. You know, all your different gears, upshifts and downshifts. Okay, this is really one of the two centers of, or locuses of control for the compensator feed system, the other being the exhaust back pressure ball. And that's in the upper valve body. Alright, again, apply clamping force. Looks like we're sitting at 20 inches of lift, so that's very healthy. And then now let's do clutch select valve number 2, inboard. That's going to be 305A. It's like 18. And then 305B, which is your outboard spool. And that is 19. Double check 305A real quick. Okay, so both were 19. Okay, so if you didn't catch what I was saying earlier with the machine on, if the compensator feed valve is worn, you know, the bore is worn, and let's just say it was only holding, I don't know, 8 inches of lift, that by itself is sufficient to explain clunky, bumpy shifting. So transitions from 2 to 3, 3 to 2, you know, 6 to 5, upshifts, downshifts, anywhere in the drive cycle. You know, leakage or weakness in this bore just by itself could explain a lot, if not all, of those drivability symptoms or types of symptoms. So, you know, again, that's the compensator feed circuit. If you want to know more about it and what it is, how it works and all that, just check out my compensator feed video that's in this general 6L diagnostic and troubleshooting series. I go deep into the weeds into that system and how it works, and you know, the impact it has on the functionality of the transmission. And it applies to all of the General Motors 6Ls and to some extent the Ford 6Rs and the ZF, you know, ZF 6 speeds. They're all based on the ZF6. So the while I think each OEM refers to this system by a different name, the principles of design, intent, and function are all the same. So anyway, this lower valve body is actually very healthy. Usually this bore is fairly worn. That's not a big deal in and of itself in terms of, like, you know, can we salvage it, because both Sonex and Transgo make you know, drop-in valves that will address that issue. Same with the clutch select valves. Both the valves and the springs can wear. So the clutch select 2 and 3 play an integral role in that whole compensator feed system. And if they're worn, then again, that's going to produce you know, inconsistent shifting, drivability symptoms, and complaints. So the TCC regulator valve is also a very critical valve because it is the kind of locus of control mechanically for the torque converter clutch, which, if you know anything about these transmissions, I would say that is by far the #1 problem with them. The torque converters, they like to fail. A lot of that is due to the design. The design is, the converter clutch itself is very weak. It's got, I think, a 20 thousandths thick clutch in there. Should have like a 50 to 70 thousandths thick clutch. So when you go back with the unit, you know, on overhaul, or you're replacing a converter proactively, make sure you get one with a at least a 50 thousandths thick converter clutch. And I would also suggest getting a converter with at least a flanged hub. if you're doing any kind of heavy duty towing, hauling, or high performance. And a bill of cover is also recommended if the towing is going to be frequent, towing, working, etc. And again, same with a lot of high horsepower, high RPM stuff. So as you can see, all of the valves in this lower valve body have a significant role to play in the compensator feed system. So if you have impairment here, you'll want to address it. Otherwise, the transmission is not going to function quite right, and it'll be drivability symptoms even when it goes back in. All right, that's the lower valve body. Let's go ahead and get the upper valve body, get the plate for that bolted on, and we'll conduct that test. All right, now we're ready to go with the upper valve body. So the other major component to the compensator feed system is located here, and that is going to be your exhaust vac valve pressure relief ball, which we're going to test at location 206A. All right, so the rest of the locations are as follows: 1, 2, 3, 4 clutch boost outboard and inboard, or balance spool. Then you have your 1, 2, 3, 4 bore plug, your 1, 2, 3, 4 regulator and shuttle outboard, center spool, and inboard. Then you're going to have your 3.5R bore plug, and then your center and inboard spools. This bore plug also will, let you test the outboard. And then you have your 3.5R clutch boost, outboard and inboard. And then next set of valves are going to be your 2.6 regulator. First you have your bore plug, and then you have your outboard spool and your inboard spool, and that's the 2.6 regulator, or regulator valve. All right, already mentioned the exhaust backfill, bore 207. That's going to be your 4.56 clutch boost. So you have your outboard and your inboard spools, and then bore 208 B and A are going to be your CBR1 4.56 clutch regulator valve. You're going to test the bore plug, and then you're going to test the inboard spool, and then lastly you're going to test your actuator feed limit valve, and that's this bore right here, number 209. All right, let's fire up the machine, and then we'll record our values, and then from here I'll kind of just summarize the valve body results, and then we'll move into testing the pump cover. All right, so we have our 1, 2, 3, 4 clutch boost valve outboard on 201B. It looks like 18 and a half. Okay, you want to also apply a little bit of downward pressure here. This is general rule of thumb with these test plates. I mean, they only give you like 2 blowhole locations for most of these castings. They only have 2. So you're going to need to apply a little bit of downward force just to make sure that you're fully seated flush between the plate and the casting. This looks like it's 18 and a half. Okay, now we're going to move to 202. This is going to be our 1, 2, 3, 4 regulator and shuttle valves. So here's the bore plug. 23 and a half. Okay, next is going to be our outboard spool for the same valve. And it looks like 21. A little tight, but again, not in any kind of danger. I mean, if you're a little bit tight like this, some bore polishing with bench buddies will, fix it right up. So here is the center spool. $19. And then our inboard. So you have your 1, 2, 3, 4 regulator and shuttle valve in this valve train. Okay, this is tight. It's 23. Alright, now we're going to move to the 3-5 in reverse regulator valve. So that's going to be 203C, B, and A. There's our bore plug. That's a little weak at 19.5. Again, plenty of options in the aftermarket for bore plugs. So here's the center spool. $16.5, maybe 16 3/4. I'll record it as 16.5. And then our inboard spool. The inboard spool is 20.5, maybe 20, somewhere in that general neighborhood. I'm actually going to record 20. It looks like it's closer to 20 to me. Okay, now we're going to move to the 3/5 arc clutch boost valve. So that's going to be 204B and A. So outboard and inboard. Record 20 there. And then we'll do inboard. So we're not getting a reading. So before we do this particular port, you're gonna have to plug this location. Okay, there's a couple of them like this, so just be aware. Okay, 19, that's what I'll record. Okay, next, we'll go ahead and move to the 2.6 regulator valve. So 205C will be our bore plug. Okay, for a bore plug, this is weak, so again, same deal, replace it. 16.5. Okay, our outbound spool, 2.6 regulator valve. Ironically enough, that's very healthy. That's what you'd want to see for a bore plug. So we're at 23. And then inboard's going to give us 18. Alright, now we'll move to the exhaust backfill pressure relief ball. And that's exactly what you want to see, 25. Anything less, then that would be a problem. And this thing's not serviceable, so you'd have to replace the casting. Alright, now we got the 456 clutch boost. So we're going to have our inboard and then our outboard. So 20 inches. And then And for the inboard, again, same deal. You're going to have to plug the little oval-shaped orifice on the other side, or cutout. This will give us 20. Alright. CBR1 456 clutch regulator. Bore plug. 22. And then inboard. $17, and again you got to plug an orifice. So, not really an orifice, a bowl hole location, but you got to cover it just the same. Alright, last is going to be the actuator feed limit valve. Okay, 23. Okay, so to recap, and I think I mentioned this, I mean, it was, you know, I know we're in the same video, but it seems like it was a while ago. This valve body, I assembled it with no corrective valving, no springs, nothing in the aftermarket. It literally is as it was from the factory. So overall, it's a healthy valve body. You got a couple of bore plugs that would need to be replaced, but for the most part, you know, if this was part of an actual job, I would be liking what I'm seeing. And so if I was trying to reconcile, you know, some sort of drivability symptom that would be associated with weakness in one of these or one of the valve trains in the lower casting, you know, I would have a little bit of difficulty there based on these test results. Okay, we're at the home stretch, 2 castings down, 1 to go insofar as testing. So now we're at the point where we can test the stator support for the pump. So this aluminum portion of the assembly is also referred to as the pump cover. So if you hear me use that term, I'm referring to this portion here. The steel part is the stator itself. Alright, so a couple things we need to do to prep. First, have your upper valve body casting handy, because you're going to need to pull out the actuator feed limit valve and pull out the TCC limit valve from its bore so that you can insert the AFL valve into the TCC limit bore location to test that particular circuit. The reason you need to do that has to do with the design of the TCC limit valve itself. So it's got a bore through here in the center of the valve, and then it has an orifice so that when you go to test this with this valve installed, you'll get a 0 reading because all the vacuum is going to escape out of the orifice. So the dimensions of the inner spool for each of these valves is exactly the same. So if you want to double check, you can use either a micrometer or a good pair of dial calipers, but regardless, you should get a measurement of 353 thousandths of an inch. Okay, they're exactly the same, so that enables you to test this TCC circuit using the AFL valve. Okay, sorry about that glare. So when you insert this valve, you're not going to insert it all the way inboard. It's going to go in about 80% or so. And the reason being is that if it were to be installed all the way in, you would have a little sliver of daylight between the body of the spool and the case wall here. And that sliver is going to allow all the vacuum to escape, so you won't be able to seal off the bore. So what we're going to do is when we have the tester and the block over, we're going to need to go and take some needle nose pliers, small pair of needle nose, and we need to hold the valve in place, because what will happen is when we go to test, the vacuum will actually suck this valve all the way inboard. So you'll see vacuum for like a split second on the gauge, and then it'll drop to 0. All right, you also want to have your little 125 thou thick nut handy. Remember, we put this nut between the TCC regulator and TCC shuttle valve.
So we have to do something very similar, but this time with the pressure regulator valve. So we need to drop this nut so that it sits between the inboard spool of the valve and the inner casting wall here. And that basically strokes the valve outboard by 125 or so thou of an inch. And we do that for the same reason that we do it for the TCC limit, and that is to seal off that circuit completely so that we can adequately test it. So there's 4 total circuits that we're going to evaluate on this stator support. So we have the boost valve, which is going to be tested right here at this location. We have the pressure regulator valve, which we're going to test here at this rectangular cutout, as well as the little orifice. Then we're going to test the TCC limit valve right here. And then the TCC control valve circuit, which is right here. And when you test this with the test block over, you have to take a finger and plug the TCC orifice here on the front of the pump. Okay, a couple of just obvious things. This stator assembly, if it were to be used in a rebuild, would have to be completely resurfaced. So you want to do this kind of testing before you spend any money on machine work. If the casting is no good, or it's such that you have to replace it, then obviously that would be money wasted. So the stator itself, you just want to check inside, make sure that there's no sealing ring grooves cut into the sealing surface in the inner diameter. And then you check your splines both on the converter side as well as the front sun gear side. These splines engage the front sun gear, so when you go to drop the pump assembly in, sometimes it'll stop or get stuck about maybe a 1/8 to a 1/16 of an inch away from the case deck surface. That's because these splines haven't fully meshed with the splines on the inner sun gear, or the front sun gear, I should say. The other thing I'll make mention of before we do our test is if you're working with a 2006 through 2008 or possibly early 2009 model year unit, and it has a first design stator, then you want to retro a second design stator support assembly to that pump body / bell housing. Okay, you never want to reuse that first design. Nothing about the stator support itself changed. The design of the hydraulic circuitry that's in here, dimensions, everything else is exactly the same. And the stators are exactly the same except for the sealing ring groove area here. This is what changed. This is the only thing that changed, but it's a significant change. They introduced the concept of a layered sealing ring configuration. And they also made these rings such that they lock in place like this. Whereas the first design sealing rings, they can freely rotate throughout the entire circumference of the sealing ring groove. So the reason that this change was made was due to the number of warranty claims associated with cross leakage between the 1234 and the 35R clutch feed circuits in that first design. The problem was that there was not enough outward sealing pressure for these rings against the inner diameter of the 35R clutch drum such that it enabled a 100% seal, or at least an adequate seal. Okay, there was a lot of leakage, and in some vehicles it was worse than others due to just different instances of tolerance stacking. But the point is that GM realized that they needed to make a change to these stators, and the sealing integrity was not sufficient with that first design, so they introduced the second design. So you have your locking sealing rings, and then what they did to create that outward sealing pressure is that they machine these grooves a little deeper, and they have you install support O-rings. They put support O-rings, which are rubber, underneath these Teflon style sealing rings. So that created that outward sealing pressure against the inner diameter of the 35R drum, and therefore the instances of cross leakage and warranty claims associated therein dropped pretty significantly. So if you suspect that you have this problem, you can remove the control body complex, your TECM, your valve body, speed sensor, and harness assembly, and you can put air here at the 35R and the 1234 locations, and The best test to do is just put shop air at the 1, 2, 3, 4 and put a finger here just over the 3-5R orifice. And if you feel a whole bunch of air, or you see a whole bunch of fluid coming out of here, assuming you're doing the test with the transmission still in the vehicle, then you know you have a cross leak. And the only way to remediate it is to yank the transmission out, and at that point, overhaul it. I mean, you're not going to just replace the stator and stator support assembly. You're going to overhaul the entire unit at that point. So, anyway, let's go ahead and flip this over, and we'll begin our testing. The first thing I want to do is make sure I'm still calibrated accurately. Like I said, these things will drift on you, so you want to make sure if you're doing a lot of testing or prolonged testing evolution, you're testing multiple castings in a sitting, then you want to just check the calibration periodically. So to do that, you just take the test hose out of the test block and stick it in the calibration port. And what we want to see is 5 inches of lift when we turn this on. And then when we plug the calibration hole over here, we want to see the vacuum jump up to 25 inches. And then when we remove the finger, it should fall right back to 5 and stay there. We'll make a micro adjustment. Alright, now I'm going to go ahead and I'll plug the calibration port. We're at 25 inches. Back down to 5. Okay, good to go. Alright, you just always want to make sure that the hose is fully inserted into either calibration port or the test block. Alright, so the first valve I'm going to work with is actually going to be the TCC limit. So what you want to do is insert your actuator feed limit valve, and the valve needs to go in roughly 75% to 80% all the way in. Okay, you want to make sure it's fully sealing this circuit. Now, like I said, as soon as I put vacuum to this, we're going to get a reading for about a split second, then it's going to drop to 0. Okay, make sure you're positioned. Apply a little bit of a, clamping force to it. You don't need to get crazy, but in fact, because I'm thinking my arm might be in the way, I'm going to turn it on first. And now we'll go ahead and just set it up. Okay, you see that? So they had a reading, and then it went right to 0. So what we need to do is we need to have our pliers handy, little needle nose pliers, and we're going to pull out and hold the valve in place so that we can test it. Alright? And it's going to want to come out of your hands, or I should say out of your the grip of your pliers. I don't know, maybe you have Gumby hands, you can kind of fit them in there. So hold it in position. Make sure you got a good firm grip on it. About 80% the way in, so it looks like it's about 22 inches of lift. So then it very quickly drops to 0 once the valve is sucked all the way into it. Okay. So now what I'm going to do is I'm going to go ahead and drop my little 1/8 of an inch nut in behind the pressure regulator valve. So just take a screwdriver, kind of wedge it, pry it forward, drop it in, and then release the valve. Alright, so here on the instructions, it's kind of the direction they give you. And they just have you block that valve so it's outboard stroked by, you know, 1/8 of an inch or so. Okay, so now we're going to test the main circuit, that rectangular port. A little awkward. Trying to get it so that you can have an unobstructed view of the gauge. Okay, and you may have to kind of move the block over the cutout to make sure you're aligned. It's not very wide, but this is showing us 8 inches of lift. And 8 inches of lift is very weak for a pressure regulator valve or any hydraulic circuit. So obviously we know we'll need to take action here. And that's over the orifice. So as I mentioned, there's plenty of aftermarket solutions available for these pressure regulator valves. So that'll drop right in and address this sort of issue. You know, it'll fix the problem. Okay, one thing I'll mention, and I don't have one handy, I'll flash a picture on the screen, but if you take apart one of these, pressure regulator and boost valve trains, and the valve, at least the inner spool, looks like a cam lobe on the pressure regulator valve. It looks like it's been, assaulted with a grinder. Chances are this bore is not suitable to reuse if your only recourse is to use drop-in valves. Okay, if you find that the valve itself is so misshapen, it's worn so extensively that it most likely, if it looks like a cam lobe, it most likely damaged the bore beyond repair, or I should say beyond remediation, with just a drop-in valve. So there you're going to want to run Sonic's oversized pressure regulator valve kit, and you'll need reamer, the fixture, the jig, all the associated tooling that Sonic's makes in order to perform that repair. I'll do a separate video on that. It's kind of outside the scope of what we're trying to do here, but suffice to say, if you're doing this, as an individual as opposed to a shop, this may be your transmission or a family member's or something, you'll have to make a judgment call for yourself, but it's probably not worth the money to spend all that outlay in tooling that you're going to use once. So it's a lot more cost effective to just simply go get another stator support assembly that doesn't have that kind of problem and replace it. I mean, you can get these good used for like 50 bucks, and so that'll fix it. And again, you always want to make sure you're going to run a second design stator, so you don't want the first design. So if you have that problem and it's a first design, then it's an easy decision, right? And then the other thing too is if you have a healthy pump cover, but there's something wrong with the stator itself, you can replace just the stator. They press in, they press out. Here are the bolts. And you also want to make sure that you replace this gasket too. The stator support gasket will leak on you after so many miles, and so you want to make sure you replace that. All right, let's go ahead and test the boost valve. So make sure that you've covered the entire circuit, including the kind of pointy end there. All right, looks like we're at a little over 18 inches. So we have good sealing integrity between the boost valve sleeve and the casting wall. So that's good news. And then the last thing we're going to test is the TCC control valve. So again, you want to plug this hole right here to do that test. And you want to make sure that you have your little gasket covering the entire circuit. So I'm just trying to find a position where I'm not interfering with your view of what's happening. All right, 22, little over 22 inches. Okay. All right, so I've recorded a reading of 20 inches on the converter limit, 8 inches on the pressure regulator valve, 19 to 20. I recorded 20 for the boost valve, and the converter clutch control valve 22.5 inches, a little over 22 inches. So overall, this stator support is in good shape. Okay, we do need to install a different pressure regulator valve. So assuming this was going to go back into a transmission as part of a rebuild, we know that, or at least can be very certain that a drop-in valve would work, provided this thing doesn't look like it's been, ground off or, completely misshapen. So when it comes to taking the boost valve out, you have the roll pin, but the roll pin doesn't have access points on either side of the casting. So what you actually have to do is just simply hold this upside down like this, push the boost valve in, and then you have to get this to kind of fall out. Sometimes you got to bang it on the bench and it'll come out. So if you note the wear here, you see it's pretty aggressive. This is very common. And that's why I wasn't holding any vacuum. Okay, this spool's fine. The outboard most spool before you get to the front of the valve's fine. This intermediate spool is also okay. But the inboard spool looks like crap. I mean, this is not the worst I've seen by far, not by any stretch of the imagination, but it's no good here, and this testing kind of exposed that. So that's why you do this sort of testing. I mean, you can visually look at this, but sometimes it'll have a lot of the anodizing still, still on the valve, but it'll still test weak. So visual inspection, in some cases, is more than sufficient, even if you don't have this kind of equipment. But in other instances, it does require some specialized testing, procedures to pinpoint areas of weakness with the stock valve. Now, that said, if you don't have this equipment and you're a do-it-yourselfer, don't despair. Just make the assumption that this valve is going to be no good, and you're going to install a correction kit anyway, like a Sonex zip kit or a Transgo repro kit, and both of them come with valves that you can put in here. Central Valve Bodies has a valve as well, but I know the Sonex zip kit has a drop-in valve in it, in that kit, and then the oversized pressure regulator valve kit, the one that you need the reamers and all that stuff to install, that will fix the valve and the bore permanently. So I can get the boost valve out of here, see if it wants to come out. So same deal with these things. Drop-in solutions come in hydraulic correction kits for these transmissions. Okay, so that wraps up all of the testing. So let me go ahead and kind of put this stuff back together, get these valves back into their respective locations, and then we'll go ahead and we'll summarize the results. All right, so we are pretty much done with all the testing we're going to do today. So what did we learn, and how would we use and apply that information in terms of go forward action plans or next steps? In a hypothetical scenario where this was your transmission, this was your valve body or your two valve body halves and your pump cover, how would we proceed from here based on what we learned? So first off, the valve body itself, the upper and the lower, is in very good shape. It's actually not very common that I see valve bodies that have this good sealing integrity across every single hydraulic circuit here. Not one area of weakness. So we know we're dealing with a great basis in terms of command and control and integrity therein when it comes to the valve body, the mechanical brain of the transmission. All right, we also learned that the pump cover is in, for the most part, good shape as well. We do have weakness at the PR valve, the pressure regulator. Again, not anything that's overly surprising. Usually the pressure regulator valves themselves are pretty beat up. This one's in good shape. It's just simply wore out the bore a little bit. So plenty of solutions available in the aftermarket between Sonex and Transgo central valve bodies. There's not any real fear that we wouldn't be able to remediate that and reuse the Stator pump cover otherwise as is after it gets machined, resurfaced here on the working area. Occasionally you'll have one of these come in where the pressure regulator valve is so worn out that the inboard spool looks like a cam lobe. I mean, it looks like somebody took a grinder to it. If you see something like that, and I'll flash a picture on the screen to kind of give you an example of what I'm talking about. If you see something like that, you'll want to replace this pump cover. You do not want to reuse it, regardless of how the other circuits test out. That would tell me that the circuitry or the casting back here is probably gouged out to an extent that unless you completely ream it out and install an oversized valve, you're not going to want to reuse the casting. Okay, drop-in valves are not going to be an option for you. Not the case with this particular example, but it can happen, and I've seen it before. So, just to take a quick recap of the results. The lower valve body, again, very good sealing integrity, especially this area has kind of the hydraulic brain or heart, if you will, locus of control for the compensator feed circuit and the torque converter clutch apply circuit. So that's your regulator valve. And then, of course, you have your compensator feed, which both of those valves are often worn. And so there are corrective valves available for them as well, as I mentioned earlier. Your clutch select valves, again, Transgo has the clutch select valve kit that could be purchased separately and independent of anything else that they or somebody else might offer, so you can install those, as well as the springs. The springs changed. I can't remember exactly when they changed. I mean, it was earlier in the life cycle in the 2000s. I'll put the exact year on the screen, but the early models had issues with those springs being too high tension. In other words, it would take too much opposing force in terms of fluid pressure to get them to stroke, or get them to yield, I should say, causing drivability issues. Later models did not have that concern. Transgo, and I believe Sonex too, but I know for a fact Transgo has a separate kit that will allow you to replace the springs with their springs in those earlier units that were affected by this design weakness. As far as the pump, so converter limit valve is very healthy. Again, we have the AFL valve installed as a proxy. Pressure regulator valve was weak, but no big deal. Plenty of solutions, as I mentioned. Boost valve was very strong. The boost valve would be replaced anyway in these. I mean, I'd never reuse the pre-existing boost valve and sleeve. And then the converter clutch control valve was also very strong. For the stator support and stator, specifically the stator itself, not the aluminum part, there were two different designs of stator. There was a first design and a second design. Second design was introduced in 2009 to replace the first design, and the key changes made were to the sealing ring grooves themselves. Okay, nothing else about the stator changed. It was a sealing ring groove design. So the first design had a traditional sealing ring. Okay, it just, you put it on, and it's sealed against the inner diameter of the 3/5R clutch drum. The problem was it did not seal all that well. You know, when you apply that statement across the entire population of units produced, a sizable fraction of those, far more than what you would expect, what we would call background failure rates, had to be swapped out under warranty because of cross leaks occurring between the 1, 2, 3, 4 and the 3/5R apply circuits. And so the root cause of this was insufficient sealing pressure or outward sealing tension between the ring and the inner diameter of the 3/5R clutch drum. So what they did is GM redesigned this portion of the stator and introduced what we call a support O-ring underneath. They also changed the upper and lower portion of the groove area so that it would accept a locking style sealing ring. And so this sealing ring doesn't really move other than this little bit, as you see here, when the 3/5R drum's rotating inside the unit. So between these two changes, this dramatically reduced the amount of warranty claims associated with cross leaks and other hydraulic driven problems with these transmissions. So when you're going back with a 2006 through 2008 unit, you want to make absolutely sure that you do not reuse the first design stator. Always retro a second design stator support assembly, just like you see here. You know, after doing the requisite testing and machine work on the working surface and installing your corrective valves, you want to go back with that second design, okay? Because the aluminum portion of this whole thing never changed. It's exactly the same from 2006 to 2021 or 2022, whenever the last of the 6L90s went out of production. I think they were installed in vans or something. That seems to be a recurring theme with GM. The vans were always the last to have a given type of transmission before its replacement fully phased it out. But anyway, this never changed. So you can press this out and reuse your existing pump cover stator support if it's in good shape, and just acquire a standalone good use stator for the second design, and press that in and give you a good opportunity to replace this gasket here, because this gasket has to be replaced on all overhauls anyway. It is another source of potential cross leaks, so you want to make sure you address that as well. All right. I think that comes to the end of our journey here with respect to valve body and pump cover testing. I hope this video was informative for you. I hope it kind of connected even more dots and kind of put things into even more of a well-rounded perspective when it comes to the inner workings of the 6L transmission and its like-kind counterparts for Ford and for ZF. And I will go ahead and put resources in the description. The links to those will include the ATSG manual, the Sonex instructions for testing these transmissions, their valve bodies and their pump covers, as well as the ATRA webinar PDF that has all of the different changes through the 6L family throughout all the years from 2006 to 2022. And that'll give you a lot of good information, because like I said in the way beginning, a lot of times trouble codes like performance codes associated with solenoids and the TECM will actually be driven by weaknesses in various hydraulic circuits here in the valve body. And so you want to make sure that you're up on those changes and how to interpret what you're seeing in your OBD2 center when you're pulling trouble codes and running diagnostics using your scan tools. So anyway, as always, thank you so much for watching, especially if you made it this far into the video. I know it's a long one, so I really appreciate it and hope it was worth your time and your investment. And if you have any questions or comments, please go ahead and leave them below. Otherwise, until we meet again, enjoy the rest of your day and your evening, and I look forward to seeing you on the next video.